Welcome to MariaDB Serverfest 2020 and a Galera cluster for MariaDB presentation. My name is Seppo Jakolo. I'm a CEO of Codership and a MariaDB developer. Codership is the smallest technology company focusing in research and development for open source replication solutions. Galera cluster is our main product. We have been working with that since 2008. We do business through MySQL and MariaDB consulting and support, mostly with MariaDB Corporation. Since 2007 we have been doing continuous growth and our team is growing constantly. Here is the agenda for this presentation. This is about Galera cluster in MariaDB, the latest features of that, so it's more technical. There is another presentation in MariaDB Serverfest, which operates more like an overview on an introduction to Galera clustering. In this presentation I first talk about Galera releases, how Galera came to be in MariaDB. Then the newest major features, practically Galera 4 in Maria 10.4, and new features we have been adding in MariaDB 10.5, and also some features that we plan to put in 10.6. The development for 10.6 has already started with our team. Galera cluster development, it started in 2008. It was first only for MySQL, but quite soon we all started to develop also versions for MariaDB. Up to 10.0 release, the Galera clustering in MariaDB was an add-on product, so you had to have a separate installation for MariaDB Galera cluster. But then since 10.1 Galera has been integrated in MariaDB mainline, so if you have a MariaDB 10.1 or later, then you also have a Galera product included. It's only a matter of configuring your MariaDB server to work as a Galera cluster. 10.2, 10.3 were just minor releases from Galera perspective. There were many major versions, of course, for MariaDB, but for Galera clustering, not that big improvements. But in 10.4 we had a Galera major upgrade. We started to use the latest Galera 4 replication there. It included also the replication API change, so the integration or migration from 10.3 to 10.4 requires more attention because of this. And 10.5 came out this summer. It's the latest from our side, and in this presentation I look mostly on the features that came in 10.4 and 10.5 and also the new features planned for 10.6. When we talk about Galera releases, we have divided major releases with just a small integer number. We started with 1, 2, 3. Now the latest one was called Galera 4, and that's present in MariaDB 10.4 version. The replication API that we call VSREP API, it has also integer number, but it goes from 1 to 26, so there has been much more API changes than the major Galera version changes. But what matters for the end user is that whenever the replication API is changed, then the upgrade can be more challenging. It requires a rolling upgrade path, and that's what actually we have to do in our development, so that we test that carefully and provide a way to have make it possible to upgrade a full operating cluster without any downtime to the new version of Galera replication. Galera 4 releases in 10.4, it included this API change, as I said. The latest VSREP API is number 26. The biggest feature that we brought in there is streaming replication. Streaming replication was originally implemented to support big transactions or long-lasting transactions as well. Here is an animation that how streaming replication can support a long-term and a big transaction. We have a client and a free node cluster. When the client starts a big transaction, it first launches in the first node, but as soon as we detect that the transaction has a big size, we replicate it to the cluster so that every node in the cluster will also launch a matching stream replication transaction. And when the transaction processes, it provides some result sets. All these results are then replicated, so the transaction is live in all of the nodes in a cluster. So in a sense, it's a distributed transaction processing system. And when the client finally commits, all these transactions will commit in the same time. It looks quite simple from surface, but developing this and making sure that it's always safe to use that, and it's also safe when there are changes in the cluster. Let's say that the node goes down or more nodes join to the cluster while there are ongoing streaming replication transactions. The cluster does not know that when the transaction eventually will commit, so there is no guarantees that upfront that we could decide that should we wait or not for certain operations. The cluster must be able to handle all possible situations. Because of this, and to make it safe, the development cycle for streaming replication alone was very long. It was like 3, even 4 years to take it from drawing table to the final release. We were suggesting streaming replication already for MariaDB 10.3, but it didn't catch that train. Then it was delayed, and finally in 10.4 we got the streaming replication in the MariaDB releases. GTID compatibility work started for 10.4 and is now present in 10.5 release. It's a work done by Mario Caruso. The underlying problem or the challenge of GTID support is that Galera has a GTID of its own. It has two elements, UUID and a sequence number of the transaction, whereas MariaDB has a free element free element GTID with domain ID, node ID, and a sequence number. The plan and design for GTID support now for Maria 10.5 is to make Galera cluster to also provide similar GTIDs in the format of MariaDB. For this reason, we use the same domain ID and node ID in every node in the cluster, so that the end user of MariaDB cluster would see the cluster as just one single MariaDB server with the same domain and node IDs. Galera cluster will now store and show for the end user only MariaDB format GTIDs. And Galera cluster can also operate as a slave for external MariaDB master server, and the GTID coming from the MariaDB master is also preserved in a Galera cluster, so you can find the same transaction that was committed in the MariaDB master server. You can find the same GTID also in the binlog files of a MariaDB Galera cluster. Cluster error voting is also a feature that came with the 10.5. It's work by Alexei. The idea here is that there is a new protocol for cluster nodes to agree what to do when one or several nodes in the cluster have problem in applying of incoming transaction. The problem could be suspected inconsistency or some other reason for not being able to apply the transactions. Here is an animation how it goes. We have one client sending a transaction, maybe a problematic one, and a 5-node cluster. The client finally commits the transaction. As usual, the commit is replicated to the cluster. Cluster is happy with it, so the commit gets OK status packs. Client thinks that commit was successful. Well, it was, at least in the first node. But the applying of this incoming transaction, it can happen somewhat later. And in this case, 2 of the nodes have problems in applying the transaction. So they saw that this is not possible. And now the error voting protocol kicks in. The first node seeing the problem sends a message to the error voting protocol, and then every node in the cluster starts to vote, telling that what was my success with this incoming transaction. The healthy nodes say that okay, this I had no problems, but 2 of these nodes tell that I had a problem. And when every node sees the votes coming, then the nodes that see that they are in a minority, they will just shut down. And as the end result, we have only 3 nodes in a cluster. From the end user perspective, he issued a transaction. It was good. And also the cluster is good after that. But 2 nodes went down, so the DBA should step in and take another look at why these 2 nodes failed to apply the transaction, and then fix the problem if there is some, and then rejoin these nodes back to the cluster. XA transaction support work by Daniele and Leandro. What we mean with XA transaction support is that we want to make it possible for Galera cluster to operate as a resource manager in an XA infrastructure. So there's a transaction coordinator somewhere else who wants to operate with several resource managers, where a Galera cluster is just one of these resource managers. So Galera cluster should be able to prepare an XA transaction, and after prepare to either roll it back or commit. If it has prepared the transaction, it also must be able to commit if the transaction coordinator wants him to commit the transaction. This XA transaction support is possible after we implemented the streaming replication. We use the streaming replication as a foundation for running XA transactions. We had this work already ready for 10.4 release, but it was not accepted there, and we moved the target to 10.5, and we almost got it there. During last springtime it looked that okay, we have a Galera XA in 10.5, but what happened there behind the scenes is that 10.5 had also some other work related to XA transaction support in the MariaDB proper side, and that work conflicted with our work for Galera replication, and we had to wait to get the MariaDB XA implementation first in. And finally it came out that there was not enough time to get our work done and well tested. So we left in a situation where we had to just pull back the proposed Galera XA support for 10.5 and delayed it to be scheduled for 10.6. So it's a practically 1 year delay for getting XA support for Galera cluster in the MariaDB. I have two features, non-blocking DDL, to discuss also. It's quite long-term work that we did. My font is yellow here because this is not in MariaDB community server, it's only in MariaDB Enterprise Server Edition. For that reason, I'm not in this presentation going through the details. I'm just telling you that this work has been done. It probably will be later in MariaDB Community Edition as well. This is work by Teemu, and the idea with the non-blocking DDL is to execute the DDL in three phases, where phase 1 and 3 are blocking ones, but they are very short. We do those phases just to agree on taking a metadata log for the later coming DDL operation. And the phase 2 is the long-lasting phase where the DDL is actually rolled into the system, but the cluster is not logging that phase. There is only the metadata log protection for that operation in place. For configuration, we have one new online schema upgrade method, NBO, that can be chosen. People usually use the total order isolation, but with the MariaDB Enterprise Server it's possible to use the n-blocking operation as well. Another one MariaDB Enterprise only feature is black box, work done by Pekka. Black box, in a nutshell, it's a debug message storage held in ring buffer, in main buffer. So when the MariaDB server is operating, it stores all kinds of debug level information in a quite small area in a ring buffer, and if the server might crash brutally, we can always go back to the black box to take a look at what happens in the last seconds when the node was still running. It helps in troubleshooting a failed cluster, or we have found out also that it's very helpful in testing, cluster testing as well. And finally, the last slides of this presentation is about MariaDB 10.6 planning. We completed our 10.5 related work in early summertime. We have this XA transaction support that was practically ready for 10.5. We continue with the testing of that and also documenting it, so we should be very well prepared for 10.6 release to have the XA support finally in. But this implementation, one of the reasons to implement XA transaction was our interest to fundamentally to implement the sharding cluster based on Spider storage engine, and this work we can now do. The Spider cluster would operate like this. So we have the Spider cluster is the upper level cluster with 3 nodes using Spider storage engines, and then we have a cluster for each shard of the Spider engine. In this example, there is only one table, Spider, which belongs to the Spider storage engine, and it has 2 fragments, A and B, and each of these fragments is then served in respective Galera cluster. The left-hand side shard cluster has 3 proper Galera nodes, and the purpose of this cluster is only to serve the incoming XA transactions related to changes for the fragment A of the Spider engine table. The right-hand side shard cluster has 2 proper nodes and an arbitrator, so that would be the minimal deployment type of a sharding cluster. 2 proper nodes for data safety, and then the arbitrator for all kinds of voting situation if the cluster has some kind of hiccups in the communication. In real life, you obviously will have a lot more fragments or shards in your table, and a big number of servers needed to run these kind of topologies. But this is interesting work, and mostly because it's the way to the final way to the write scalability. The performance and kind of the workload in each shard cluster is quite minimal. It's only each shard cluster needs to care only about the data that's one part of the big table. So the load per shard cluster is quite minimal. The only question is for the overall throughput of this system is that how big a bottleneck the Spider engine will be in the upper level Spider cluster. We have started some ongoing work for 10.6 as well, so the XA and Spider cluster testing will be of course part, but some other work that we do for 10.6. We started with the test system improvements. That doesn't show up for the end user so much, but for development it's very important part. We are extending the test cavalidity and improving the tests so that they would be deterministic and not so false positives so often. It will help in a development and avoiding regressions in the future releases. Two new features have been worked on. First one is dynamic SSL or TSL encryption. Earlier you had to either use SSL encrypted group communication or not. You needed to do that up front, but now you can dynamically switch on and off, and you can change, for example, your SSL implementation to have another implementation variant of the encryption used for the cluster. This work is code complete. It's in a testing phase at the moment. Another one is the optimization for streaming replication. The way that we implemented streaming replication for the first version was very conservative and safe, just to cover all the possible error scenarios when cluster has members dropping from the cluster and joining in, and we had to make sure that it's always possible to recover an ongoing streaming transaction. Because of this, we used quite a lot of extra resources, and that caused the actual long-term transaction to last a lot longer than it would in a for example compared to a single node or a standalone MariaDB server operation. But with this optimization we plan to make the transaction throughput of such large transactions much faster. This is in a research phase, and the implementation has just started based on the design that was done in a research phase. So these three tasks are ongoing. Then we have a list of feature requests that we have got during the 10.5 cycle, and what we are hearing from MariaDB Corporation as well. The list is quite long, like 20 to 30 new features. We cannot do all that for 10.6, but during the next 1 or 2 months we will pick up the winning features that we want to put in 10.6 for the next springtime. Yes, that's about all for Galera cluster 10.5, 10.6 for MariaDB. Thank you for listening, and have a nice MariaDB Server Fest 2020.